Hello everyone. Today we are going to discuss about Boyle's law. It's one of the important laws about the ideal gases. Those discuss about the various properties about the ideal gases. So let's see the statement of a Boyle's law. For the fixed mass, that is number of moles in N of a gas at a constant temperature, the pressure P of a gas is inversely proportional to the volume V of a gas. Or, at a constant temperature, the pressure of a fixed amount, that is number of moles of a gas, varies inversely with its volume. In simple words, it tries to say the pressure of a gas is inversely proportional to volume of a gas. Let's write it in a mathematical form. That is, P is inversely proportional to V, where P stands for the pressure inside the system and the volume of the system at constant temperature. So, while performing this experiment, the temperature of the system kept constant so that we could observe the proper relationship between pressure and volume. Now, as we know that proportionality constants K can be used in the place of proportional symbol. Therefore, on sending the V in a LHS, we can write PV is equals to K, where K is a constant. That means pressure into volume always remains constant for any ideal gas at a given temperature T. Then, for a comparison, one can say the P1 V1 can also be equals to P2 V2. That means the pressure volume product in a one state or in a other state will be always equal. These are the conclusions one can bring from knowing of the Boyle's law. Let's understand the Boyle's law in more detail. For that, we will perform few experiments. Let's see an animation. Now, in coming animation, this cylindrical shape object will be a cylinder of a system in which we will contain the gas, and the T-shaped piston will be used to compress or expand the gas inside the system. Now let's see. Let's say the cylinder is empty and filled with air. Currently, the pressure inside the cylinder is as equal as pressure in the surrounding, that is 1 atmospheric pressure. Then let's add the piston into the system. As soon as I plug the piston into the system, the air from atmosphere will get compacted inside the system, and the air particles will be creating the pressure inside the cylinder as a PCYL, that is pressure inside the cylinder. And the gas molecules will be wandering all over inside the cylinder, occupying the entire volume of its. Now let's see what happens when, if we try compressing the volume. So by compression, you can see the piston is moved inward to the system, and the atoms needs to come closer. The gas molecules needs to come closer to each other. By pushing it inside, the pressure inside the cylinder becomes more greater than the surrounding, and gas particles have a less space to move. That means the pressure of the cylinder has increased due to the compression, and this increased in a pressure causes decrease in a volume. As you can see, there is a less space to move for the particles. Now, what happens if we perform expansion? Let us take another system, and this time the gas particles will occupy more space as the piston is pulled outward, and that will make the pressure inside the cylinder goes less than that of surrounding. And now you can see that there is a lot more space for gas molecules to move, to wander inside it. So here you can see the volume of a system have increased, but due to the expansion, due to the piston pulled outward, it have created a suction effect, a vacuum effect inside it that shows the lowering of the pressure. Now, by comparing this both properties of a compression and the expansion, one can see the relationship between the volume inside the cylinder and the pressure of the cylinder are inversely proportional to each other. Now, let's observe it with real life practical. This is a very simple practical that you can perform at your home as also. For that, you will need two materials. So materials that will be used for the coming experiment will be a syringe of a 50 ml and a regular balloon, any normal balloon, so that we can fill the air inside it and to observe the changes. So, are you ready with your material? If not, just watch the video and you can bring the materials and perform it. So, let's do the experiment. To perform Boyle's law experiment, we need a syringe and we need a simple balloon. Now let's fill air in the balloon, not too much, just a little, and we will immediately tie the balloon so that air shall not pass out. We will not try making it so big so it won't fit into not that big so it won't fit into the syringe. It should be little small. Now let's take the syringe. I will open up the syringe and let's put the balloon inside the syringe. And now I am going to seal it. Now close the tip of the syringe. As soon as I will start pushing the piston inside, the air inside the syringe will start compressing, and we will observe what happens with the volume of the balloon. So let's start compressing it. So as you can see, more the pressure I apply on the syringe, on the piston, the balloon compresses. Do you see? The balloon has compressed. So more the pressure, less the volume goes. And as soon as I start releasing the pressure, it increases the volume and balloon can regain its shape. Now let's try other way around. Now I will try pulling it outward. By doing so, inside the cylinder the pressure will decrease, and that will cause some change in the volume of the balloon. Now if you can see, there is some volume already inside the balloon of the air. Now let's see what happens when I try creating the vacuum inside it. It won't be a completely vacuum, but the pressure will be definitely decreasing. And now you can see, as soon as I tried creating a lesser pressure environment inside the syringe, it shows increase in a volume. So decrease in a pressure causes increase in a volume. That means it's working inversely proportional way, as the Boyle's law stated. By using the syringe and the balloon, we have proven that the volume and the pressure are inversely proportional for ideal gases. Although the gas I am using is not the ideal, but still you can see its relevance. So that is where the Boyle's law is proven. As the Boyle's law stated, the pressure is inversely proportional to volume. I hope guys you like the experiment. Thank you for watching.